Yeah, I figure we'll just get straight into it. So, if for everybody who's watching and not here with us live, which is everybody because we're not doing this live, we're going to talk about Harrison's new book, The Learning Design Patterns with Unity, which I just got a copy
Yeah.
of very recently and is pretty excited about because there really aren't like a lot of design pattern books out there. Definitely not for
Yeah,
games,
no.
and I don't think there are any for like Unity and C Sharp examples, at least that I could think of.
No, there's one. So like there is like a previous book that's like game development patterns for Unity.
Oh,
Um,
okay.
but that one, I don't know, that it's an older book from past. But yeah, I couldn't find uh any newer ones that were like specifically included a lot of Gang of Four and like game programming patterns like together specifically
Yeah.
for Unity. I don't think that exists.
That's what I'd always had a really hard time finding was something like that because it's like that game programming patterns book, which is great and available
Yeah,
online for free, but it's not in
yeah,
Unity, so sometimes people have a slightly harder time kind of relating
yeah,
it. In this book, like I feel like you've got all of that stuff, but like a whole lot more. When I opened it up, I mean, when I picked it up, I was like,
yeah.
oh, this is another big, heavy book. It's got a lot of stuff,
It's
but it's all design
heavy.
patterns. It's not just full of
Yeah.
like a bunch of extra fluff. Although there is a bunch of funny stuff in there too, which I always enjoy.
Right? Like, I don't know. I have a conversational writing tone, which either gets me in trouble or gets people enjoying the book. So it's whoever likes that, that's fine. I can't really fix that. That's just how it writes. But yeah, so Robert Nistrom's book is great, for like theory, but yeah, it is in C++, and it's, um, like the examples are very like targeted. So there's not like there aren't full projects. They're like code snippets. So like it's illustrative. It's not like hands-on or comprehensive, and it's super good. And I took some of the like patterns that I see more and that I find useful that go well with Unity. So it's like 75% like original Gang of Four and like 20 or 25%, 80/20 about of like game programming patterns specific.
Yeah, and yeah, you get into some really specific Unity things too, like integrating some of these patterns with scriptable objects. Obviously, how they
Oh
tie
yeah.
in with the engine, game objects, and
Oh yeah.
everything else. Because there's a little bit of an abstraction there if you're writing it and thinking about it in a written from scratch engine versus like actually in the ecosystem. And I guess
Yeah.
you talked a little bit about. Or you mentioned a second ago about like picking patterns that you found really
Mm.
commonly used that were maybe not necessarily just the obvious Gang of Four patterns. Did any of those stand out as ones that you found really interesting or think people would find really interesting in here?
I mean, the one I use the most is an observer pattern, just because it's already built in. But rolling your own is like it feels good, and it's very like in terms of like programming pattern or design patterns, it's fairly easy to understand because we all kind of get the publish subscribe like model of how that works in real life. We do that a lot, so that one is always a good one. The one that surprised me the most that I didn't know I was kind of splitting my time with was type object. And like type object and flyweight are very similar, but they're kind of conflated and put together in like into this weird little like Frankenstein thing, and then it's put out and taught. And like parts of some people's flyweights are type objects, and parts of some people's type objects are flyweights. It's like type objects work really well because they're basically um, like composable scriptable objects. So like it's a wonderful thing. You don't have to have it like they're separate patterns. So like type object in C sharp, I mean it's usable, but like with scriptable objects, it's awesome. Like I made the example in the book is like how to make um Pokemon evolution trees without class hierarchies. They're all composable scriptable objects. And you can inherit base Pokemon, you can inherit base type objects and build these like as complex as you want these objects with like a completely flat hierarchy with two classes. And like to me, when I learned about that a few years ago, I was like, oh, that would have made object composition so much easier in my head. Like, oh, we can just stack them. They can inherit and they can be stacked, like without an actual subclassing hierarchy. It's like
Without
that.
having to
That
make
blew my mind.
two and every
Nope.
single class, and that's where it starts, and then you realize these things start to come up with these patterns. Real quick, for
Right.
anybody who's listening and watching and doesn't know the difference between those patterns or doesn't have any clue what you're talking about, you just give like the
Oh, sure.
elevator pitch
Yeah,
for what the two are.
I guess we skip that because like
We're going to skip and assume that if you watch this, you at the very least know what events are. If not, then get the book right now. Either way, you
right.
should probably go get it. We'll link it down below. But yeah, can you explain those two?
Yeah. So okay. So like flyweight is more known for performance and optimization, and basically the example everyone uses is like trees. You have a huge forest, and and even if you're doing this not in Unity, it still applies. But you make these tree objects. They all have a mesh, a color, and a position. And really, if you're using the same trees, only one of those things is different. It's the position. So you don't have to replicate the the texture, the color, anything that they share. And that's called intrinsic state. And what you do with a flyweight is you literally make one copy of this shared data, and all the flyweights, uh, or you reference that, and that's your flyweight. And any of the objects that you create, like more trees, just reference the same tree material, the same tree color, the same tree texture, whatever you want.
And just by like
But
a tree ID or some reference, right?
exactly.
Some
And you can
in
grab it from a
memory.
factory. Yeah, exactly. So you only instantiate each type or each base value set once. So,
Mm-hmm.
you have a pine tree and you only have to initialize the texture once. And you just pull from it and make a million of them. It doesn't matter. And all you have to do is feed it, an X and Y position and you plant it, right? And so, if you make a million trees, you're only referencing one texture. You're sharing all this state. And it works even better if you have, 10 types of trees. You have 10 flyweights, make 10 million trees. You're still only referencing 10 objects. So it's really, really powerful when you have a lot of objects to create that are very similar, that don't change a lot. And so like that's a performance thing. That's strictly like manage your performance, keep your frame rate up. Don't, if you have enemy, like in games, if you have, enemy waves coming at your player, in like a really big number, that'll just crash your frame rate if you're initializing textures for each little one and maybe multiple textures.
Yeah, and I feel like another, just to add on to that, outside of the just rendering and kind of, because a lot of these things are kind of done with game objects and built in with the engines, you
Mm-hmm.
get situations like inventory items. You don't want to have like say I've got 10 of the same item. You just reference that one item ID. There's that one thing instead of 10 copies of it in memory, which
Mm-hmm.
on 10 copies of an item doesn't matter, but you get to a larger scale game where you've got a ton of items, you got duplicates of the items, or even worse, like a multiplayer game, get to an MMO, and if you tried to copy all
Mm-hmm.
that data in there, you're just going to blow it all up. And it's really just an
Yeah.
optimization around speed and largely on memory usage, though, on the coding side, right? So, like on the rendering side, there's a lot on the performance. When we're writing code, most of the time, if it's not engine code, it's around the memory optimization, right?
Yeah. Exactly. And like with the inventory item thing, you only have to keep track of the quantity of each, how many of each item do you have? And you just, reference the one thing, which is
Yeah.
great. So that helps you with your performance. That helps you with your memory, with object creation, with like instantiate, like using the new keyword that creates a new object. You want to limit that. With a type object, you basically are injecting the type of object into kind of a container class. So in games, you could have like a monster. Instead of having all of its stats, you would have a breed. That's the classical game example. And you inject this breed into a monster, and the monster just figures out that, oh, I'm a dragon because the breed is a dragon. The monster class doesn't know what it is until you give it a breed. And it takes
Mhm.
all its information from that, which basically means that with a monster class and some kind of breed class, you can make like wildly varied objects or monsters. You can have a zombie, you can have a ghoul, you can have a dragon, you can have as many layers deep as you want without a subclass hierarchy of having like a monster as the base class. And then you've got like a dragon and then like subtypes of that. And you have this crazy deep tree, like nested tree of a class hierarchy to get these monsters. And to, I mean, I guess it helps you more the deeper you go of not having to like override properties, like to get a really customized monster. Because if you do that in a really nested subclass, it's going to ripple all the way up your class hierarchy and end up breaking things. And that requires a lot of work to maintain that kind of structure. Like it's a lot of work. And like, you know, if you're making a game or an application and suddenly, you know, your customer comes to you and says, you know, I want to do, you know, a promotional thing. Can you add 5 new monsters? And you're like, okay, well, that's either going to take me like 2 weeks or it's going to take me 2 days, like to figure that out depending on what your class structure is like. So they both handle, this is where it gets confusing. They both, at least for me, they both do performance, but the intent is different. Flyweight is strictly for memory and performance. Type object is for object composition, and you kind of get the performance and memory optimization for free, like on the side. But that's not the intention. The intention is to build complex objects from a flat hierarchy without having the subclass. So you get kind of a round, you get object oriented fun and like, you know, features without actually tying yourself to it and getting bogged down when you need to make a meaningful change, which is difficult with really deep subclasses.
Yeah, so when you want to start adding in new behaviors and stuff, what's the example? You said, was that the Pokemon example here?
Yeah, so type object has, yeah, so we do like basic enemy stuff just in C# with like stats. And then when at the end of the chapter we get into scriptable objects and you know, like we have a game object, you have a capsule, you have a color, and the Pokemon has base stats and types. And because you can still inherit with scriptable objects, or I'm sorry, with the type object pattern, you basically get to create a like mix and match Pokemon Pokedex. Like you can breed them basically. So you can put like a grass with a fire and you'll get a grass fire with their combined weaknesses. And that's what'll come out. Yeah. But with only 2 classes. Like that's really hard to do without this pattern. Like to do that traditionally with object oriented programming.
Yeah, that seems like a fun and really useful one too. These patterns, once you start to get familiar with them, solve a lot of, I think, really common problems in easy ways, right? I mean, that's kind of the goal of design patterns, is giving names to really common, well-working solutions to common problems that people come across. I mean, obviously, observer is probably the most obvious because things need to listen to other stuff and be notified. I'm curious, what were some of the other most popular ones? Or
like the core ones that you can, like, I feel like you can do the most with are like observer, state, and strategy. And then maybe command on the end of it if you have like some kind of turn-based state that you have to, that you want to package. But like with those 3 or 4, you've got like the core of every application or game that you can think of. Like there's stuff, you know, if you're going to use like object pooling, which just is like going to the library. You just only have a certain amount of copies and you recycle them. That's like, you don't really need that out of the box. Like that's an over optimization. I think like it's cool, but like unless you really need it, maybe like leave that out. But like object pooling, type object, flyweight, those are all optimization patterns. But like starting out of the gate, I don't think it's necessarily like a wrong move or a bad move to like have an observer, like a simple observer system set up, like to think about how you're writing game mechanics and like, oh, those seem like different strategies for the same thing being done, like the same work done differently. Like, you know, you should start thinking about these things even if you don't implement them right away. But I mean, those are like, yeah, state, observer, command, and strategy kind of do a big chunk of the work. Like those are the workhorses.
Okay. That sounds about right to me. You called something out though that I want to talk a little bit more about, which was implementing them right away. So I assume as soon as you read a design pattern, the first thing you need to do is go figure out exactly where you can shove that into your code, right?
Yeah. Always. That's the exact thing you should really don't do that. Please don't do.
I've done it. I'm pretty sure that's the right way.
Right. No, please. I don't. I love this stuff so much, but please don't do that. It causes so much grief. Like that's why I took when I was writing this, I got a lot of feedback from people I know and from early reviewers and people I asked questions about, and who are much farther along in their development careers. And I'm like, okay, if I asked you like point blank what you would have wanted to know about this stuff in the beginning, a lot of people said when to use it, not how to do the pattern. You can Google how to do the pattern. Like understanding like developing your analytical eye for identifying problems and seeing the possible solutions that will fit that problem. And like unfortunately that's why the first bit of each chapter is kind of like theoretical. It's like trying to warm you up to this is only good in this and this case. Anything else you gotta find another way to do this because this isn't a fit. And like I always kind of end the chapter with like, please don't rush off. This is not the pattern to rush off and be like, oh God, this is going to solve everything. Because you have to have the problem to have the solution. Like, it's fun and cool to create like the abstraction layers, but like if you rolled your own service locator, which is, for people who don't know, basically a registry of classes you would normally make singletons, like you would like access managers, like you don't need that with a prototype. Like it's not there yet. And
You don't
someone's
need
gonna look at it.
in service, right?
Yeah, right. You're like you have one service, like, and you roll like a generic service locator that uses like reflection and bogs down your game that way with one or two services.
The one
Yeah,
static. Yes.
you're like, okay, that's like it's wonderful. It works, but like that's not the solution because you don't have the problem.
You don't actually have the problem. Yeah. You want to implement
Yeah,
these as you have problems. Or one thing you
yeah,
might notice is that you've already implemented them in your project or somebody else has, and it's just not
yeah,
called out. Things might be named slightly differently. They call their command something that's not a command, but it's the
yeah.
same pattern, right? Or
Yeah,
something similar.
you'll see the system, and the system is still the same. Like whatever it is, the system you'll be like, oh, I recognize that. And that's the hard thing. I tried some design patterns can be like you can see them and you can see them in action, you can see them in production, or you can see them online as they're taught, and they're taught from like the most optimized solution first. And it's really confusing because it's not always very clear how they got there.
Yeah.
And like design patterns for people who are very versed in them, I see this a lot that they kind of skip abstraction steps. They combine things to make it a little easier, a few less scripts. It's not as, spread out everywhere. And that works fine as long as everyone, is in the know. But you get someone new in there and they're like, oh, like, where did this go? Like, how did this get here? So that was kind of another area of research when I was writing was like, not to skip steps or make assumptions, but like we literally build from the easiest implementation to, I mean, the most efficiently implemented, like kind of complex one. So like we use a little bit of reflection, not too much. Every chapter kind of ends almost, yeah, I think like 90% of the chapters end with scriptable objects because they work really well, surprisingly, with design patterns.
Oh yeah.
Right. And like usually we'll have a little bit of Unity classes sprinkled in there if they apply. So like with the observer pattern, we go over like Unity actions or Unity events
Oh.
versus C# events and C# actions and how fast or slow or how do you compare them past a certain point. Um, so yeah, we go from very basic to very complex, and that's unfortunately why the book is so heavy and why I
I
had to leave.
book myself. It means that I've got lots and lots to read. I don't like the little
Right?
thin ones. I just tear through them too quick. These things but it's nicely organized too. You've got like each chapter is pretty independent, and you can just jump to whatever pattern you want and start to learn. I feel like it's pretty
Yeah, I
easy to
mean,
follow.
that was the challenge at the beginning was whether to make like a more reference book that you could read from front to back or jump in or to like kind of lock people in and you have to start at the beginning and you're going to make one project and implement all these design patterns. I felt like that was not as useful as like being able to jump in with a problem and like
But you have to
look it
kind of
up.
contrive the problems too to get all of the problems for all the
Oh my
patterns
God. I
game.
thought about that. I was like, I got to the point I was like, I don't think I can fit all of these in one project. I just don't think the pieces fit in like a project that feels good. We'd have to build a game. It would have
You
been
gotta
nuts.
make
Like,
10 problems. Yeah, because like every game's gonna have different ones, right? And different scenarios. So yeah, that's a tough one. But I think you did a great job with this one. I really like it, and I'm definitely going to be
thanks.
recommending it to people going forward. I think it's a perfect starting point for somebody getting into design patterns, especially if they're in C# and Unity already, because things are going to relate way more than the Java or C++ examples and stuff that you normally get, which like loosely relate. Like you can tell the kind of the structure, but you're still kind of left like wondering like, well, what does the code actually look like? And then you have to go try to figure that out and find more examples. And I like that this is all in Unity.
Yeah, I mean that's what I think took the most amount of testing was like making the systems work like with like as simply as possible, but you still have to have like an empty game object in your scene. You have to have a client. You have to have something doing like requesting the work be done, and like getting those moving parts seems to trip a lot of people up, rightly so, because or at least at the like the audience I'm targeting, because you're not as like it's not as second nature yet. Hopefully, like I hope people are getting this earlier than I did, because like by that time you're like
in their career, not right at the peak where they've already all the patterns. But I feel like if you have the patterns down, it's good to have. But yeah, get this thing right away.
Right, like I don't know. It was odd to think of like writing a reference book with the idea to like train like an analytical skill, even though like the book is the book seems like hard skills, like this is how you do it. It's really not. Like there's so many ways you could do these things, but if you know the problem, how it's trying to be solved, like you can get there on your own. And like I do focus a lot on that at the end of each chapter. Like there are so many variations, and I fit quite a bit of them, I think. But like at the end of the day, after a certain point, you can't teach a design. You've gotten to the end of the design pattern because it fragments into like so many unique use cases. So like you have to. It's weird to find that line.
Yeah, well, like I said, I think you did a great job in here, and you've covered. What's the total count of design patterns in this book?
There are 18. There are 18 in this one.
18.
I had to leave out 14, so I got more than half. I think that's pretty good for one book. Yeah, the other ones, I wish I had been able to. I ran up against a page count on Amazon, so I wish I was trying to shoehorn in event queue and mediator, because those are very useful and they're like middle niche. Like they're not super niche and they're not like super applicable all the time, but they're very nice. Like it's so I think if I can, we'll see what the next edition happens or if I get a volume 2, but there's still like 13 or 14 patterns that are useful. They're just not as useful. Like
just need to get like a giant extended edition that's like the size of one of those like old Bibles.
Oh my God. Maybe we'll just do a digital like extension. Like if you buy this one, you can have access to like the other ones online.
Yeah. Oh, and that's true. You do have the digital version of the book available if you get the print one, right? And the codes.
The code samples are just free, like open on GitHub. And yeah, you can get the digital or the package. You can get physical and digital. But it also comes with a Discord link for our server. I'm in there. A bunch of other Unity authors are in there. You can answer questions. You can come and show us work. It's cool. We got a lot of different stuff in there. Yeah. So there's a little QR code in both versions that you can get. So
that is really cool. Yeah, you guys got to go check it out. Now I got one more question about the design patterns. On all of the patterns that you taught, what was the hardest, or what did you find like people have the hardest time really getting, understanding, and actually implementing? Or maybe there are one or two. I don't know. I feel like there's a couple that are really easy and common, but there's got to be some that just people struggle with the most.
Yeah, I mean, all right. So there's like one people struggle with C sharp, and there's one I think that people struggle with in Unity. So with Unity, I think it's flyweight. Oddly enough, even though Unity itself has flyweight pattern implementations, like shared materials, like that's a flyweight pattern if you use it correctly. If you don't, okay. But that one is a little bit more difficult to do because the flyweight as it's taught with C sharp doesn't deal with objects, like with physical 3D objects. So like shoehorning that in gets like you have to, that was difficult for me to get to work without like when still getting the memory optimization.
Right.
So the flyweight and the like coming up with an example for like unshared flyweights are basically not flyweights, which is odd, but they do work and they're like planning for the future, which is nice. But that's a hard niche example to like show, especially with 3D objects, because it's usually data that you're saving.
Right.
So in Unity, that one was very complicated to figure out how to teach correctly where it would still have the desired effect. For C sharp, I think a lot of people get the command pattern wrong, which is odd because it's so useful. But a lot of resources mix up or don't differentiate like reusable commands and one-off commands. And they're very different because they handle your state of your command and your objects differently. And they're like, you have to use one or the other. Like it doesn't work to just have this.
You don't want to mix and match them, and sometimes they're stateful commands, sometimes they're not.
Right? I mean, you could, I guess, but you'd have, it would always be an odd mix. Like it'd be an off percentage, like for however you're doing it. But basically, like if you have commands that you're going to reuse all the time, they can't have like state tied to them because you're reusing them, you're recycling them. So that doesn't work. Like that works if you're doing, let's see. Well, we'll do it the other way. It doesn't work if you want to do like undo and redo systems, which is a huge thing with the command pattern. It's very easy to have stacks of commands that you've done and undo them and redo them at will whenever you want. But you can't do that with reusable ones. They have to be single use commands that have state because you have to know how to get back to the original state or to go forward. Like you have to have a history basically.
Yep.
So a lot of what I saw and what I was trying to figure out how to teach and seeing people like struggle with it was like, oh, well, I thought command pattern would solve my problem with this. I'm like, well, it will, but you have to choose your implementation. And like you could have both in your project. They just can't be mixed up. Like it's totally fine to have both. They just can't be the same type of command.
You got to kind of, I guess, determine where you're going to keep that state and how you're going to manage it. And I could see mixing and matching it would be very confusing, right? Especially when you think about some of the states in the command, and some is just some other arbitrary place that's related.
Yeah, exactly. But like, I can totally see a game needing both kinds. So that's perfectly fine. But it's hard to when people want to over optimize and be like, well, I only want one kind of command in my project. Well, then you're just setting yourself up for really difficult change requests down the line. That's going to get messy. Which it does.
I think most of the time I end up with stateless commands, but I also very rarely do undos and rewinding. It's not a very common use case in most games. And some games obviously need that as a behavior, but if the game doesn't do it and it's not a part of the game that's actually interesting, then they usually avoid that. It just got me thinking now. That's why I love these books. They can get me thinking just about random just design patterns and ways to optimize things and ways to, it gets me thinking back through existing code that I've got and other systems I've been working on. I really like this.
Right. Like, well, I wanted like, here's the thing. Like if you had a game like a turn-based simulation game, you might want to set up hotkeys and have an undo redo system. If you had like, a goal-oriented game mechanic where you need to get through somewhere and you were like, oh, that didn't work. And you give them a freebie, like you can start over. So like reusable commands are hotkey mapping. You can switch them around They don't care how they're used. They just know how they can be used. They don't know what context. You could map however you want to set up. You could put in an Xbox controller. You could do a keyboard, and it would all work the same. But if you wanted to do like give your players a chance to like navigate a maze and give them a freebie of like, oh, that didn't work. You get one more try, or you get a certain amount of undo steps. So like you could have a real, like a strategy, like a turn-based strategy game that needed both kind of game mechanics. But like, it's difficult sometimes to see that both of those are the command design pattern implemented in slightly different scenarios.
Yeah, I think it'll be interesting to have some more discussions on this too, because I could see some with a pretty deterministic game, easy ways to do it without the commands having state as well. But I think I was mentioning at the beginning of this, before we went live, that I wanted to get everybody on the Game Dev show to kind of read through some chapters and do some discussions on those. So I'm thinking I'm going to try to get that started, and then maybe everybody else who's got the book and wants to read along can join in on some of those discussions that we're having there when we do them live. I still have to convince everybody else to do it, but I think that it would be a fun and interesting idea. We could just pick one or two design patterns a week, read through that chapter and just discuss it, debate it, and let Story tell you again how terrible everything is.
It'll be a trial by fire, because again, it's gonna be like, that's totally fair. Like, that was the issue with trying to write this, choosing to focus on teaching like a skill and a perspective on software engineering, instead of like, this is the only way you could do it with this code. Like, no, you can do this.
It's much more forward when it's the basics, right? It's like, this move is the object. You don't have to think too much more about it. Yeah. I don't know. I think there'll be interesting discussions, and hopefully we can get you in on some of them as well.
Let's get it. I'll be ready.
So are there any other things about the book you wanted to briefly tell everybody about before we get going? And tell everybody where to get it, of course.
Yeah. Well, you can get it on Amazon. You can get it on PactPub or Pact.com. Both are available depending on, and both have different sales. So just check either one, whichever time of year. There'll always be either of them will be cheaper. One or the other.
Make sure you leave a review. I got to go.
Please leave a review, because then I can write more design. I can do the second. I can include all the other ones that I left out. Maybe I'll just put it up for free like Robert Nystrom. It's always an option. It helped a lot of people. Maybe I'll just do that. It helped me. Maybe I'll just do that. But here's the big disclaimer. I use the old Unity input system. I do, because it takes up less setup time, and it takes up less screenshots in the book. It's a purely, like, I put it in the book, like, I'll say it on the record. I love the new input system. I love it. It's a wonderful tool to use. But in terms of teaching, it adds a barrier to entry that is unnecessary for the type of work I'm trying to do.
In most of my videos, because it's just
like
one line versus a whole chapter of explaining.
I'm like, and I get a lot of flack for that. I'm like, I am using, that's the other thing. I use basic white boxing shapes, colors. Like, there's no art assets, there's no sound. There's always like a client and the work and the system, and you build the system to make the client, or to like get the client what it needs. And it's also, you get a starter project for every chapter, and you build the design pattern system from scratch. But, it's not, I see a lot of resources out there that kind of teach design patterns from the point of view of like, here's a kind of fairly fully featured, maybe vertical slice of a game. It looks really good. It sounds really good, and it plays very well. And let's implement a design pattern. And that gets lost a lot. It's very difficult, again, to see the moving parts of what's the starter project and what's actually being accomplished by the design pattern. So those are the two disclaimers. I do use the old input system. Very sorry. I do like very basic white boxing, and I try to make the examples fun from games that I love. Like, we made a little Final Fantasy Tactics thing for the command pattern. That was fun. Made a little Temple Run Infinity, like an infinite runner. we did a bunch of like, 2D and 3D platformer games because, everyone has played those. We've even got a little FPS in there, I think, for one of them. So, like you said, coming up with the problems and the examples to make them simple enough to start, but complex enough to be interested in, and like have it not be kind of like a throwaway, like, oh, we'll make pizzas today, because that's like a really, like, the decorator pattern is always, oh, we'll decorate pizzas. Like, okay, but how do we make that work?
Yeah, like how does that apply to a game that's not a pizza game?
Right? Or like any kind of application. I'm like, oh, this is so difficult to like to conceptualize and show people why it's why it's useful.
Yeah, but you got to move it to real world, like game or application problems to really lock people in. The two abstract examples, they're great for like here's the first example, and then you have to go like from there to here's what this means in code sense. Otherwise, it's so
do it for a use case now for your customer that they have written to you that says, that break up that and make it work.
They're not ordering pizzas, huh?
I mean, if they do, that's the most, like, pizzas and car manufacturing is always the thing I get. Like, that's, like, let's build some cars, let's make some pizzas. It's always that in some way. Like, I guess it makes sense, but it loses it. So like, I had to find different ways of getting the point across.
It would certainly engage my daughter. She is obsessed with pizza. Every time she sees a triangle now, she screams pizza. I literally had my Unity shirt with the triangle shapes on it. Goes, pizza?
Pizza? See, that's positive association. You're like, oh yeah, I know what I want. I know what I want for my life, and it's pizza.
That is definitely what she wants. Yeah, every time she loves it. It's probably my fault. Cool. Well, yeah, thanks again for joining me, man. This was really awesome.
Yeah, thank you for talking.
For writing this book.
I get a little excited. I'm sorry I talk so fast.
No, it's good. I prefer people that talk fast. The thing that drives me really crazy is when people just talk extremely slow and it takes forever to hear what the hell they're trying to say. So I prefer a nice fast one. That way I don't have to 2x.
No, man. I mean, this took me 2 years and change. Like, so this was a long time. I get very invested and excited about this. So
it's exciting stuff. So we'll have to talk more about it and get you on the live show as well. And like I said, I want to do some chapter reviews. I think it would be a lot of fun and super useful for people. If you're not already a design pattern master, you should definitely just go grab it, go on Amazon or Pact and just check out the link. It's not expensive. It's definitely worth it. And you can go learn a lot. And just remember not to just try to implement them right away. Just read through them, keep them in the back of your mind. And then as problems come up, you're like, oh yeah, I remember that pattern. Let me go read about that one more time and see if that actually fits in here. And then if you're not sure, just jump over to the Discord and start asking them questions.
Like, there's no, like, you can start this almost immediately. I don't know why people say this is like, oh, you have to wait. We guard this behind the wall of mysticism. Like, you can get started with this stuff really quickly in your programming or engineering career. Like, you can really get into it.
This is stuff that I wish like I had learned as a teenager, and that I push on my teenager to learn these patterns and learn. He's less interested in game stuff, but still programming and just making sure that learning the stuff early on so that they know the best ways, and also just be able to talk about and communicate this stuff. When people are talking about a pattern, you don't know what it is. If you don't have the book, at least go look it up. If you got the book, then go read the chapter as well.
Yeah, I mean, this will help you in an interview. Like, even just knowing,
this would be a huge help.
Knowing the table of contents, you'll be like, oh yeah, I sound like I really know what I'm doing.
Yes, it's very easy to set, especially when you realize that a lot of technical managers that are hiring are not really that technical. They're just more managery, and they don't even know these design patterns. They just know that those things exist and they've heard of them before. So if you know them, it's a good step up, guys.
It's a good thing.
That's not all. Don't get me wrong, but that's a good chunk. So, cool. Well, yeah, thanks again, man. I really appreciate this. Love to chat some more. and everybody, just go grab the book, go check it out. Leave a comment down below. Let us know what you think. If you got any questions, make sure you just go jump on the Discord and ask them away. And we'll talk more about
all the people that dive through all the like errata, send it in. I've got a whole page unpacked just for that. I know they're in there. I know I've missed some, some colon somewhere. Despite hours of combing through that, it still happens. So hit me with that. It's very useful.
All right. Well, yeah. Thanks again, and thanks everybody for watching. Don't forget to like, subscribe, and tell Harrison what you think of the book. And of course, if you do grab it on Amazon, make sure you go leave that 5-star review so more people can go find out about it and get better at programming. So then when you have to read their code, it's better for you as well. All right. Thanks.
It helps everyone.
Does improving code quality helps the world tiny bit, but it's positive for the world. All right, thanks again, Harrison.
Yeah, thanks.